Hello everyone, my name is Bhavesh Kumar and I am an undergraduate student at IIT Kharagpur. Today's topic is cyclone track detection and prediction. Starting with the introduction, a tropical cyclone is a low pressure system with a warm core that forms over tropical and subtropical waters. The tropical and subtropical oceans receive large amounts of energy from the sun. This energy is released into the atmosphere in the form of water vapor. The release of heat causes an upward motion of water, creating a low pressure zone that is set into the spin by the rotation of the earth. When the energy contained in this spiraling airflow is high enough, a cyclone is formed. Forecasting of cyclones. Forecasting of cyclones involves the prediction of several interrelated features, such as the cyclone's track, intensity, induced storm surge, and accompanying rainfall, and the coastal areas threatened. Among all these interrelated features, it is most important to know in which direction a cyclone will move so that the inhabitants of potentially affected areas can be warned well ahead of time. In this way, minimizing damage to life and property. For this reason, forecasting of cyclone track has been considered as one of the most important forecasting functions by many meteorological offices around the world. Now I will talk about forecasting techniques. All forecasting techniques have in common that they take into account the recent past behavior of the current cyclone and the behavior of previously encountered similar cyclones. Previous cyclones can be similar to the present one in terms of their creation, created in the same ocean basin and or during the same season or even the same month during a previous year. They can also be similar in terms of their behavior pattern. They may have had a similar movement track as the present cyclone has exhibited up till present time. The basic assumption is that whatever forces are affecting the present cyclone also have affected these previous cyclones, also called predictors, and that studying these predictors will therefore help to forecast the track of the current cyclone. Currently employed cyclone track forecasting techniques can be based on: first, averaging cross previous cyclones; second, statistical modeling of previous cyclones; third, numerical and dynamical modeling of general meteorological and physical forces affecting cyclones; fourth, techniques based on satellite image interpretation. So, average across cyclones. This type of techniques are also known as extrapolation, as they extrapolate and average the cyclone's current and recent past movement, usually 6 to 12 hours back in time, to produce a forecast of the cyclone's future track. Extrapolation techniques are the simplest among all track forecasting techniques. All variables affecting the cyclone movement are assumed to be constant, and as the variables are not changing, the cyclones are assumed to keep moving in the same direction as in the recent past. Forecast accuracy depends on precision selection of time-tagged recent past positions of the current cyclone, as the previous positions and direction of the current cyclone are the only two factors that are governing the future movement here. For short-term forecast, 12 to 24 hours ahead, extrapolation can be satisfactory, but for long-term forecast, this family of cyclone forecasting techniques is not adequate. Extrapolation is an example of the averaging technique and was used by the Joint Typhoon Warning Center, USA. Performance of XTRP for both 24 and 48 hours forecast is similar to that of typhoon, and here you can see the diagram or the graph showing the forecast error. The second method is statistical forecasting techniques. Uh, the statistical forecasting techniques are mostly regression based. Many statistical cyclone forecasting techniques have been developed over the years. They can be divided into the following five major types. The first one is climatologically aware forecasting techniques, climatology and persistent forecasting techniques, the statistical synoptic techniques, steering airflow flow determination, statistical dynamical techniques. The main advantage of the statistical techniques is that any combination of parameters or variables in the observed dataset can be taken into account. The computational resources required to run statistical forecasting techniques are fairly low. Naturally, statistical techniques have also some drawbacks. Statistical regression methods produce forecasts that reflect the average behavior of storms in the predicted dataset. For this reason, statistical technique perform best when the present synoptic situation, as manifest in recent storm motion, does not depart too much from the normal climatology of the basin. In addition, these techniques depends on good availability of data in order to reliably determine statistical trends in the cyclone tracks. In particular, statistical forecasting techniques can produce erroneous results when statistical trends in the cyclone tracks. The forecast is poleward and eastward at low altitudes. The forecast is equatorward and eastward north of the subtropical ridge. The forecast says the cyclone will stall or will get into a looping motion near the northern or southern subtropical ridges. The main synoptic features deviate strongly from their normal climatologic position. And the last one is the date of cyclone formation is outside the usual cyclone formation region for the basin. Now is the first subpart of the statistical forecasting technique is climatology aware forecasting techniques. Tropical cyclones formed in the same basin and during the same season have a tendency to move along similar tracks. These observations have led to the development of climatologically aware forecasting techniques. The climatologically aware forecasting techniques can be subdivided into following three groups based on predictor selection criteria and the calculation used for forecasting. The first one is cyclone forecasting through calculation of mean motion of past cyclones, analog cyclone forecasting techniques, forecasting techniques using Markov chains. Cyclone forecasting through calculation of mean motion of past cyclones. These techniques consider the mean motion of all past tropical cyclones that have occurred within a similar time period as the current cyclone. Climatology (CLIM) is a climatology forecasting technique that produces 24, 48, and 72-hour forecasts through unweighted averaging of the motion of previous cyclones in the same basin. In climatology, only those cyclones are considered as predictors that were formed in the same basin within 6 degree into 6 degree latitude and longitude of the current cyclone's origin, and that were developed during the same month or months that include the days when the current cyclones was formed. The second one is the analog cyclone forecasting techniques. Analog cyclone forecasting techniques differ from climatology mean motion detection techniques in that they are more selective when choosing predictors. But instead of taking into account all the past cyclones that have previously occurred in the same basin and within a specific spatial and temporal frame, analog techniques additionally limit the set of predictors by criteria on the speed and direction of movement. These should be similar to the current cyclone's speed and movement direction. And Huron is the most popular one analog based forecast technique. Cyclone forecasting techniques based on Markov chains. Markov chains refers to a sequence of states in which each state depends only on the previous state. For cyclone track forecasting, Markov chains can be defined on the basis of the climatological characteristic of previous cyclones that arose in the same ocean basin during the same time of year. A Markov chain that is produced in this way contains transition probabilities indicating if the cyclone will change its speed and direction in a certain way. Once the transition probabilities for the previous cyclones have been determined, the current cyclone can be forecasted using the same transition probabilities. Now, climatology and persistent techniques. Climatology and persistent techniques differ from climatology aware techniques in that they combine information both from recent and historical cyclones to get the advantages of short and long term forecast in a single technique. Moreover, the operation of climatology and persistent technique is simpler than the climatological climatologically aware forecasting techniques. Climatologically aware techniques read all the historical cyclone track data each time they are run. In contrast, climatology and persistent techniques use the historical cyclone track data only during the development of the regression equation. Uh, Clipper climatology and persistence was developed by Newman in 1972 as an alternative to Hurran to forecast cyclones formed in the Atlantic basin. The prediction equations employed by Clipper are derived using linear regression and can produce forecasts for up to 72 hours. A combination of the following 8 predictors are taken into account when cyclones are forecasted using Clipper. That is latitude of the current cyclone, longitude of the current cyclone U component of motion represents the east-west component of the wind motion during the cyclone. 12-hour old U component of motion, current cyclone V component of motion, it represents the north-south component of the wind motion. 12-hour old V component of motion, day number, maximum sustained wind speed, that is period during which the temporarily maximum wind speed is sustained, measured in minutes. Now, statistical synoptic techniques. Height over sea level and air pressures are inversely related, we know. This gradual reduction of air pressure with increasing height may also cause other changes in atmospheric variables, right? Taking into account atmospheric information from different pressure levels may increase the accuracy of the cyclone forecasting techniques. This insight about the importance of the variation of air pressure levels at different geopotential heights contributed to the development of statistical synoptic techniques. These techniques consider including current and 24 hours old upper level geopotential height data as an important factor in cyclone forecasting. The additional use of geopotential height data as one of the predictors has made these techniques stand out from the climatology and persistent techniques. A particular geopotential height or a combination of heights from the upper sea levels or upper levels is systematically selected through a stepwise screening process. Data from these heights are represented in a 3D grid where the cyclone is always kept at the center. And one of the example is Vegas Miller. The Vegas Miller technique developed by Vegas uses a multi-screening linear regression method to forecast cyclones. Development of this method was based on observations from 447 cyclones and a subset of 91 sea level pressure readings in the Atlantic basin. The multiple screening linear regression method used in this technique is simple to calculate, and as sea level pressure is the only synoptic information considered, forecasts produced by this technique are effective for longer time period compared to the synoptic techniques that use upper level atmospheric information. One disadvantage of this method is that it is sensitive to the location of the storm center within the analysis grid. Techniques based on satellite image interpretation. Cyclones usually move large distances over the tropical oceans before they make landfall. As cyclones spend most of their lifetime over tropical oceans, detailed information throughout their life cycle cannot be collected using ground-based observations. At the same time, there is a need to observe these cyclones in as much detail as possible, since knowledge of their information and previous movement pattern is important when producing cyclone track and landfall forecasts. Though the use of satellite images is common for most of the operational cyclone forecasting techniques today, some techniques use satellite images as the primary data source when producing cyclone track forecasts. Satellite image-based cyclone forecasting techniques involve interpretation of cloud patterns that are associated with the cyclone. These patterns can help determine the exact location of a cyclone and can indicate specific types of motion or changes in a track. For example, changes in the track of cyclones have been observed to correlate with the rotational changes in the storm's overall features. For example, overall cloud patterns. Like here is a figure representing like overall cloud pattern. Now, techniques using artificial neural networks. In cyclone monitoring and forecasting, satellites have become one of the most important platforms for collecting information about the cyclone and its surrounding environment. Identification of variations in the very low contrast cloud features associated with cyclones, integration of information collected through various sensors, and identification of spectral and spatial patterns have proved to be a challenging task to many traditional forecasting techniques. One of these emerging approaches is the use of artificial neural networks for data preprocessing. Artificial neural network based cyclone forecasting techniques are characterized by the following important features, that is adaptivity, the ability to continuously change the system's internal representation, robustness, seamless handling of missing, noisy or confused data to the extent that these data can be auto-completed and corrected on the basis of statistical regularities found in previously processed data. Third one is power or speed, handling of large data volumes within an acceptable time frame due to inherent parallelism. Fourth, nonlinearity, the ability to represent nonlinear functions or mappings. Artificial neural networks are advantageous in the following sense. Use of satellite images as input that are widely available and mostly free of cost. Neural network based techniques can easily be run on standard desktop PCs, so these techniques are computationally inexpensive. Although considerable time is required to train the network using all the historical satellite images. Once the network is trained, a few minutes or fractions of a minute is required to produce cyclone track and intensity forecasts. Neural network based techniques are capable of producing forecasts with acceptable accuracy. The conclusions: accurate cyclone track forecasting requires precise observational data of the current cyclone, as well as high quality historical data that reveal typical patterns in cyclone movement. The crucial factors for accurate track forecasts are well informed selection of suitable analogs from the historical data and correct identification of those variables within the selected data that affect the cyclone's track. Both of these processes can be supported by a powerful forecasting technique. The choice of forecasting technique has considerable significance for the accuracy of forecasting. That's it from my side. Thank you.